Absolute value inequalities, whether we're greater than or less than tells if it's a union or an intersection. If it's greater than, it's a union. And if it's less than, it's an intersection. And then if you remember, this is where you shade everything, or like all of both. And this is where you shade only the overlap. Of less than, you're having an intersection, so you're only shading the overlap. And this is why, because do you remember absolute value of x equals 3 meant that x could equal 3 or x equals negative 3? This is sort of the same thing. We have absolute value of x is greater than or equal to 3 gives me greater than or equal to 3, or less than or equal to negative 3. Now, when we change this, we flip this. So it's kind of like multiplying or dividing by a negative. We're changing the sign, so we have to flip. Okay? So then when we graph this one, I've got 0, 3, and negative 3. This is a union, so I'm going to get greater than 3. So that's going to shade all of this. And I have less, oh sorry, that's or equal to, so that's colored in. And then less than negative 3, so I'm going to shade all of this. I can't even shade well today. No, I only need you to know that so you kind of have an idea of how much you're going to be shading. I don't here, right? We have absolute value of x is less than 3, so x is less than or equal to 3, and x is greater than or equal to negative 3. Now, I do want you to recognize that with less than, you're going to use the word and with greater than, you're going to use the word or and. So when I shade this one, I have 0, I have 3, I have negative 3. They are both closed circles. Less than 3 will shade that way. Greater than negative 3 will shade that way. So what I'm going to be shading is the overlap. Again, I have less than 9. That's going to give me x is less than 9. Remember, a less than is and x is greater than negative 9. So if this is 0, this is 9, and this is negative 9, I have open circles, less than 9, greater than negative 9, so I'm shading in between the two. I've got y greater than 3, greater than is an or. So yeah, greater than or equal to. So it's going to be y is greater than or equal to 3, or y is less than or equal to negative 3. So here's 0, here's 3, here's negative 3. I've closed in circles. Greater than 3, less than negative 3. So when I shade, now here's where it will matter to recognize whether you have an intersection or a union. If this was less than and somehow I ended up with this happening, then there would be no intersection, so it would be no solution. When we have the word and, but then we get this kind of a graph, ands only are the overlaps, so then this would be no solution. It's very, very rare where you would end up with a situation like that, but in absolute value. So less than again is an or. So, oh, wrong pen. X is less than 5 or x is greater than negative 5. Okay, this is an or, which means sorry, not an or, an and. God. That's my own bad brain right now. 5, 1, 2, 3, 4, negative 5. It's an and, so I'm shading in between the two. Right there. Okay. Okay, so what happens with negatives? The absolute value of x is greater than negative 5. Absolute value is always positive, yes?
Yes.
So it's always going to be greater than negative 5. Correct? So this is going to be all real numbers. So we would shade the whole thing. If I asked you to graph it, you just shade the whole thing. Yeah, the other one would be no solution, right? Because if we look at this, absolute value is always positive. So absolute value can never be less than negative 5. So this is never true. So this is no solutions. And so you don't graph it. Absolute value equation until the very end with the split. The split is where the change happens. So to get that absolute value by itself, I'm going to add 5 to both sides. And I get 2 times the absolute value of x is greater than 14. Then I'm going to divide by 2. And I get the absolute value of x is greater than 7. So I'm just going to rewrite that up here. So then from here, I split. And I get the absolute value of x, or sorry, not just x. X is greater than 7. X is less than negative 7. That's going to be an OR. Open circles. And I'm shading greater than 7, less than negative 7. Not fraction, division. So I'm going to multiply both sides by negative 3. And I get the absolute value of y. Now what happens when I multiply by negative? Is less than or equal to negative 12. Absolute value less than a negative. This is false, right? So there is no solution. Or you can write no solution. And you don't graph anything because there's nothing to graph. When we have a variable, an expression inside, we still do the split, but then we solve. All right, so I'm going to do m plus 2 is less than 11. M plus 2 is greater than negative 11. So I split and I flip when I change the sign. Then I solve each one individually. So if m is less than 9, m is greater than negative 13, this is an and. I'm just going to randomly pick spaces and say that they're that far apart. I have greater than negative 13, less than 9, so I have this overlap. That's the part I'll shade. To split this one, I get y minus 1 is less than or equal to negative 2. Wait a minute. Hold up. What am I doing? Anybody catch my mistake? Yeah, less than a negative, there's no solution. Okay. This one is also no solution. Let's just make that one positive so that we can solve with a multiplication in there. So we just change it. You can't change it, but I have the power to change it because I'm me. Yes, and I have that kind of power. So I'm going to split 2c minus 5 is less than 3. 2c minus 5 is greater than negative 3. I'm going to add 5 to both sides. 2c is less than 8. Divide by 2. C is less than 4. Sorry, that's so squished. Add 5. 2c is greater than 2. Divide by 2. C is greater than 1. So I've got 0, 1, and 4. I am less than 4 and greater than 1, so I'm shading in between